All right, so we're going to work another day on u substitution, and these are going to be kind of special cases where we're still going to do u substitution. We have a little extra that we have to do with it. So we'll call this topic 6.9, day 3, and this is going to be u substitution when there's an x you don't need and you can't distribute. It's a really long title. I didn't know what else to call it. But so there will be an inner function, so we will need to do u substitution. So there's going to be an extra x in there that isn't part of du that we have to figure out something to do with it when we write everything in terms of u. So let's just go straight to an example. So for example 1, we're going to find the indefinite integral. Right, and our integral is integral of x square root of 2x minus 1 dx. Now, I can't distribute that x inside of the radical. All right, and then you can tell that there is an inner function. The 2x minus 1 is an inner function, and the derivative of that is 2. So du is 2 dx. Now, I'm still going to have to correct my integral. So I still need a 2 dx. I don't have the 2, but I do have the dx. So you would multiply by 2, and you would multiply by the 1/2. And so I would be okay with changing 2x minus 1 to u and changing 2 dx to du. But I have a problem, and it's that I still would have an x in my integral. And at that point, I only need to have u's. So we have to think, is there a way I can write x as a u? And there is. We can take this function or that equation and solve it for x. So if u is equal to 2x minus 1, x should be equal to u plus 1 divided by 2. I'll just solve that little equation for x. Okay, so then I can go ahead and change all of my x's to u's. So I still have the 1/2 in the front. In the place of x, I'm going to write my, what I just found that it was, u plus 1 over 2. Then I have the square root. In the place of 2x minus 1, I put u. And in the place of 2 dx, I put du. Okay. Now, it's still going to be kind of a challenging problem to do even after we do that, but we can do it. One thing I want to do is I can pull a constant out in the front. So u plus 1 over 2 is the same as u plus 1 times 1/2. So I'm going to pull that 1/2 out in the front, and that's just going to leave us with u plus 1. And then I'm going to write u to the 1/2 as, I'm going to write the square root of u as u to the 1/2. Okay, now I still have some things I need to do before I can find the integral, because remember, there is no power or product rule for integration. So I would go ahead and multiply those 1/2s together. And then I'm going to need to distribute the u to the 1/2. Right, so don't forget that, I know this is like back in Algebra 1, but when you multiply, you're always, you add the exponent, so I'd add 1 and 1/2 and get 3/2. And then 1 times u to the 1/2 is u to the 1/2. All right, so finally, I'm ready to find the integral. All right, so I'm going to add 1 to 3/2, and that's going to give me 5/2. And then I could divide by that, but to save a step, I know that dividing by that is the same as multiplying by the reciprocal. All right, then I would do the same thing here. So I'd take 1/2 and I would add 1 to it and divide by that, or multiply by the reciprocal. Okay. And we just need to simplify this a little bit. So I'm going to distribute the 1/4. So I do know the 2 and the 4 would reduce down, and I would end up with 1/10. And the same thing on this one, the 2 and the 4 would reduce down. I would end up with 1/6. And then because this is an indefinite integral, I do need to do that last step where I change back into x's. And that is it. Okay, so sometimes there's that extra x that you can't, it's not part of your du and it's not part of your u, and you just need to solve it, or write it also in terms of u. Just a little extra step at the beginning. All right, so let's do one that is a definite integral. So for example 2, our directions are to evaluate. And this one for me took up a big part of my paper, so I don't know how big you're writing, so you may need to start on the back. So we're going to do the integral from -5 to -2 of x times the square root of x plus 6 dx. Okay. So we can tell that we have an inner function. We can't distribute that x, so we are going to need to do u substitution, where u is the inner function. The derivative of that is just 1, so that works out kind of nice that we don't have to correct. In that case, we have everything we need for du, but we still have that extra x. So I'm going to take my u function and I'm going to solve it for x. Okay, now don't forget, when we are doing these definite integrals, we need to change everything to u's, including the upper and lower limits. So I would take -5 and plug it in for x in the u function. That means I'm just going to add 6 to it. And then same thing for -2. And then in place of x, I'm going to write what x is in terms of u. And then same thing for the square root of x plus 6 would be the square. Let me just go ahead and make that u to the 1/2. The square root of u, or u to the 1/2. And then for dx, we're just going to write du. Okay, so I'm going to go ahead and distribute that u to the 1/2. right, and then I'm ready to find the integral. So I'm going to add 1 to my exponent and then divide by my new exponent or multiply by the reciprocal of it. And then same thing for this one. Right? And then this one we are not going to do plus c because it is a definite integral. So we would do the bracket and then put our upper and lower limits there. All right, so I'm gonna do quite a bit of cleaning up before I do the fundamental theorem of calculus. So I would multiply those together. Okay. And then, because I'm going to try to do this my best without using a calculator, I'm actually going to factor out that 2/5. Now, we wouldn't have to do that, especially if we were just using a calculator, but I want to show that to you just because it will, like if it's on a non-calculator part of your test, you are going to need, to be able to work with these numbers without a calculator. So dividing it out of the first term is easy. But factoring 2/5 out of 4 might be kind of confusing for you. But don't forget, when you're factoring out, you're actually dividing by that value. So we're taking 4 and we're dividing it by 2/5, or we're multiplying it by the reciprocal. And then that is just going to simplify down to 10, which is a lot easier. It's going to be easier to work with than the 2/5. Okay, so I'm ready to plug in 4. So it's going to be 4 to the 5/2 minus 10 times 4 to the 3/2. All right, and then from that, I'm going to subtract when I plug in 1. Now, plugging in 1 is super easy. When you raise 1 to any power, it's just 1. So I technically could just leave it as 1 and not worry about raising it to a power. However you want to write it. Okay, so then to raise something to the 5/2, you're going to take the square root and then raise that to the 5th power. So the square root of 4 is 2, 2 to the 5th is 32. All right, and then to the 3/2, we do the square root of 4, which is 2, and 2 cubed is 8. Right, and then this just ends up being 1 minus 10. So it's just a bunch of crunching numbers at this point. So that's going to be 32 minus 80. It's negative 48. And then 1 minus 10 is negative 9. All right. And then negative 48 plus 9 is negative 39. And then finally, I would just multiply that by 2. And we get negative 78/5. All right, so the crunching numbers part to me was the most challenging part of that problem. Or not challenging, just time consuming. All right, so your assignment is just some problems out of the book. On page 302, I want you to do 48 through 62 even. And I want you to know, especially when you get towards the second group as you're doing the definite integrals, you may not have to do this new technique every time. So don't think that just because it's on this lesson's homework, you have to do that. So you may not have to use the new technique on every problem. Now, a good portion of them you do, but there are some, particularly starting, like, let's starting with the definite integrals, because you may not have to, or you definitely don't have to. Like, it won't work if you do. So, like, starting on number 56. I'm hoping you'll recognize it on your own, like when you have to do it and when you don't.